Hello everyone. So in this video we will talk about one of the most important topics in software engineering, which is object oriented design. So before starting this topic, let me tell you that before starting any of projects, please have a good design. Always have a good design before start coding, no matter how big your project is or how small your project is. If your project is small, at least have a design in your mind. If your project is a large scale project, you can have a project documentation documented in proper documentation means. But please remember, before starting coding, you have to have a very good design. Otherwise, when you start coding, you will be in trouble. So object-oriented programming is one of the ways we can design software. There are other ways of designing software such as functional programming, but in this video we will talk about the concepts of object-oriented design. So object-oriented design is characterized by 5 concepts, which is explained by the acronym SOLID. So we'll discuss what are SOLID principles. So in SOLID principles, S stands for single responsibility principle, which means each component in your program should have a defined responsibility. It can be a function, it can be a class, it can be a service, it can be anything, any component. And when someone asks you the question, what does this piece of code do, you should have an answer. So your responsibilities should be properly defined. And we'll move on. And next we have O for open closed principle. So in open closed principle, what we discuss is, if you want to add new functionality to an existing class, always extend the class and make a subclass of it. Do not keep on adding functionalities and new functions to the same class. And if you want to add new functions, just extend the class. That's it. Do not keep on adding everything to the same class. Then it will be very easy for you to maintain and very easy for anyone else who will be working on your project to understand what you have been done. So moving on solid principles, we have L, which is for Liskov Substitution principle. This is a concept which many people find it hard to understand. But Liskov substitution principle is a very simple concept, which means at any point of time you should be able to substitute a superclass object with a subclass object. So in other terms, when you extend your superclass in your subclass, you should always remember to follow the behavior of the superclass. You should not write something really different in your subclass. If your subclass implementation of a method is something very different from your superclass implementation, that will break this principle. So always use subclasses to extend your functionality. Do not use subclasses if you need the completely different behavior. In that case, you should not actually extend your class if your implementation or if your expected behavior is completely different. Maybe you should write a completely new class. So remember to follow Liskov substitution principle. When you extend a class, keep on adding things to the existing behavior. Do not introduce something completely new and break the logic. So always your superclasses should be able to substitute it by subclasses. That's it. So moving on solid principles. After Liskov substitution principle, we have I for interface segregation principle. This simply means each interface should serve only one defined task. So what is an interface in this case? This can be a service endpoint. This can be a function. So any service endpoint or any function should serve only one task. It should have a defined purpose for its existence. Do not do multiple things in one function. Then your code will be hard to maintain and it will be very much error prone. So in simple terms, have one function for one task. So as I can shown in the example here, if you write a function something like create or update account, that is not following solid principles. So you should have create account separately and update account separately, and that's what we mean by interface segregation principle. Every function should have a defined behavior and one function should not do multiple things. And moving on to our final principle, we have dependency inversion principle. So this is something I have seen many software engineers, especially new ones, do not follow. So always your components should depend on the interface. It should not depend on the implementation of actual logic. If you do that, your components will be tightly coupled. If you depend on the implementation of your components on one another, then if you change one component, you will have changes on several components. And if you are working on a large scale project, this can be a nightmare. So always follow dependency inversion principle and remember to code for the interface. Do not code or do not depend on the actual implementation. Always write your implementation after writing your interfaces. So you can kind of design your logic based on the interfaces and then move on to write your actual implementation. And that's it for solid principles, and hope you find something new or you refresh your knowledge from this video, and we'll meet in another video. And thank you everyone for watching my video, and let's meet on another video. Thank you.